down!
Construction details, we made it very simple construction, just mainly model rocket technology. Approximate cost was $30, flight cost was $20. So then we proceeded to 6-scale model. This is going to be a proof of concept for composite construction. We was planning on using this for testing some of the smaller systems, and we ended up flying it with a commercial Aerotech I-284 high-power model rocket motor.
Nice and quiet. 5, 4, 3, 2, 1.
Yes!
Oh, that's gonna crunch hard.
That's okay.
Not that hard.
Yes.
Construction of this is a little bit more complicated. We used a piece of sonotube for a mandrel, used 4-ounce glass with epoxy, and then a layer of 3/8 inch pink house sheathing foam with another layer of 4-ounce glass with epoxy, and then after everything cured and hardened, we removed the sonotube for the main tube. Fin construction was flat 3/8 foam with 4-ounce glass on it. Standard high-power model rocket motor mount. Motor standoffs were made from 1-inch pink foam with 4-ounce glass. We designed the whole motor mount system to be removable, so we could put in different motor sizes and types. The fins were built up similar to aircraft wings. Fins bolted directly to the motor mount through the body tube. Total cost of this thing was about $100. Flight costs were about $60 with composite engines and approximately $10 if we used hybrids. Future projects that we have planned are a half-scale, and then a full-scale, possibly a sport design, a 2-stage, and then a cluster complex configuration. One of the issues is money. Admittedly, this is a very cheap program, but I know everyone's asking us, how am I going to pay for all this? Currently, I'm doing this all out of pocket. I want to make the plans public domain. 6-scale was delayed for a couple of months due to lack of funds, but hopefully maybe I can get some grants or do some fundraising or maybe a lottery. But regardless of the funding, this project will eventually be completed. Our next step is the half-scale model. We're going to use this as a test bed for flight, guidance, and recovery systems. We'll also be able to demonstrate proof of concept of designs for airframe, engine design, construction materials, and other building techniques. The half-scale model will be mostly composite parts. We'll have an interchangeable motor system. We'll either be able to use composite propellant or hybrid engines, and it'll be equivalent to either a level 2 or a level 3 high-power rocket, and it'll have a very large payload area suitable for testing. Then the next step will be a full-scale model. We'll be using currently available materials, which should give us significant improvements over a 1950s model. I honestly don't have an idea what we're going to get for an altitude. We're planning a 1,500-pound capsule overall. If it gets 10 feet off the ground and everything works fine, I'll be happy. Of course, after many test flights, things work well, we'll move on to manned flights. Now, at this point, you might be thinking, nah, no one's ever going to build anything that big. Well, guess what? A model rocketeer by the name of Steve Eves went and built a 1/10 scale Saturn V commemorating the Apollo's 40th anniversary. This rocket, within a couple of feet, is the exact same size as a full-scale Little Joe, such as what we would plan to build and put a person in and fly. And the next frame should be a video of their flight. Unfortunately, we don't have permission to replay that video here online like we did at the presentation, but you can see that video. It's available at www.rocketsmagazine.com. One of the ideas we was toying around was to make a sport model Little Joe, something a little bit more science fiction looking from the 1950s. Construction-wise, it's more complicated build techniques. It's cooler looking. The current design will allow such modifications, but there's no justification other than that it's much cooler looking. Other things we're looking to further on will be a two-stage model of the Little Joe, which would end up being the equivalent of Redstone. Hopefully, if we get enough performance improvement, we can get orbital with this thing. If not, we will definitely get a space flight out of it. We are not going to do it until we are absolutely sure that we can get just the basic Little Joe to work for us. One of the other things we're also considering is a multi-stage or a cluster. The equivalent of maybe a Gemini or an Apollo rocket. Since Little Joe pretty much is going to be a modular system, we can do a variety of staging and clustering modes. We can end up configuring these combinations to do anything we want. Two stages side by side, like the picture here, would be the equivalent of a Gemini. We do a cluster of 7 two-stage tubes. It'd be the equivalent of an Apollo, Saturn 1B. Hopefully at this point you're asking yourself, well, what can I do to help? Well, you could build and fly your own Little Joe. I mean, we'll have plans on a website that we'll show later on, and you should be able to get everything you need and be able to build and fly your own. Or maybe you just want to help us fly ours. I mean, if you're in the area, send us an email and we'll see if we can't get something arranged for you either to help build or fly. Maybe you'd like to contribute in a physical way. Send us building materials. We need glass, we'll need foam, we'll need epoxy, we'll need lots of it. Tools, jigs, pumps, latex gloves. You could send us other stuff that isn't really related to the building. We could use some extra camcorders. We could use some digital cameras. I mean, if you got an obsolete camera phone, we could take and we could put in a capsule of that thing and get pictures of it while it's in flight. Maybe you want to build and fly your own. You don't think you're ready for it. Attend some workshops. Find some composite workshops. Go to a model rocketry club and ask them what it takes to build a rocket like this. Worst comes to worst, if you can't think of anything else to do, you could always just send us money. At this point, I'd like to thank you guys for looking at our little presentation here. And if you could, please visit www.littlejoeproject.com. We'll have all the information about our rocket on that website. Or you could shoot me an email directly at tater@littlejoeproject.com. I'd like to add a special thanks for RockSim for their design software, Aircraft Spruce, which is where we got some of our supplies, and NASA for all the design and plans and technology and paperwork and historical artifacts and so on and so forth. Thank you.